Okay. Today's question is what is voltage, and we're figuring out how electricity works in step-up transformers, and how like magnetos work in generators and AC generators, and how magnets create energy in copper coils that induce electrical force and cause a current and a magnetic field to happen in the wires of a copper coil. And basically, we want to know how this all is an energy that basically starts from a force that is called the conversion or the transduction of energy. So basically, energy is transduced from a source and transmitted with different components. It all really comes from a pressure and an interaction of particles. So like when we talk about energy or electricity or electromotive force or quantum particle interactions, there's lots of particles in the atom, and you need to know that the atom is surrounded by lots of different particles. There's two kinds of particles. There's fermions and bosons that they have discovered according to Fermi Labs and the CERN in Geneva, Switzerland. The world has discovered quantum particles, and they claim there's like several different particles that work with atoms that are subatomic and even at the atomic level. So these are fermions are the larger particles according to what I read, and bosons are the smaller particles, and apparently these are the two kinds. They claim that there are even particles that that may change and mutate, known as like ghost particles. They may change size, change rates of flow. They may be very strange, and you know, we got things like particles occupying a single particle occupying two different locations at one time, and things like that. But I want you to know that time travel to the past is not possible. You can see that the past may be sustained. Something about the past could be sustained. And that means that no energy has changed in a system. So if no energy is changing in a system, essentially the past will be sustained. And there'll be no future because there is no change in energy. So if you want a future, you have to change the energy. And all time is defined as the motion of an object, the motion of an object measured by a reference. That's the definition of time. So like all of this comes down to particle interactions and quantities or quantum amounts of things that basically interact to create functionality, motion, and energy, and all these things that happen in the world and the universe. And basically, interactions happen with electromotive force or potential difference expressed in volts. Protons have an energy field around them that causes electrons to have motion in atoms. That energy field is made of boson particles. And basically, it causes electrons to be in whatever state that they are. And technically, atoms seek to be neutral, or at least mostly neutral. Not entirely neutral, but mostly neutral. Very stable is what the preferred word would be. So basically, if an atom gains a charge, usually it's either partially charged or it's missing electrons, which could be a various amount. And usually, most common levels of missing electrons and state of charge is usually at what we call the the valence shell. The valence shell is the outer shell of the outermost electrons that are most likely the most easily moved electrons. The most inner electrons are much more difficult to move in an atom. And some atoms, they're noble gases that absolutely, I don't know if their electrons really move or not, but they will never ever form. Neon and helium will supposedly never form a chemical reaction. They cannot react with any other thing and bind to any other atom or molecule. And so they're mostly useless as far as it comes to to create a molecule out of neon or helium. But these noble gases are extremely stable, and they do interact. They may create electromotive force in their atom, but they usually don't create chemical bonds. Some chemicals like nitrogen, they're extremely resistive on a lesser part of the scale, but they do actually, in fact, create chemical reactions. Nitrogen is in the form of N2, and it is triple bonded to itself in the atmosphere of Earth. And that's where you mostly commonly find nitrogen, is in the air. So there may be other forms of nitrogen, but obviously humans have nitrogen in their body, and we are made up of a lot of nitrogen. And other biological life probably has nitrogen in it too, obviously. So some of the components of our molecular part of our cells have nitrogen in them. Nitrogen is a primary constituent of all life. So anyhow, voltage, we want to know that basically we want to show that in a system, if you have, this is based on Ohm's law. Ohm's law is not accurate in all circumstances, and there are things that do not obey Ohm's law. But for proportionality reasons, I'm going to go ahead and use Ohm's law. Because quite often in certain proportional circumstances, Ohm's law does work, at least somewhat. So basically, you have 12 volts divided by 12 ohms equals 1 amp. Okay, so that's the law of amperage. That's I equals E over R. That's the part of Ohm's law that states that resistance and voltage are proportional, and they're inversely proportional. That means that if you increase resistance, then the current will drop. If you increase the voltage, the current will raise. Voltage and current are directly proportional. Usually, every time that we've ever seen it in the world so far, and this is really what we're talking about, is the direct proportionalities of energy here, like voltage. So directly, with Ohm's law theory, 12 volts, if you increase it to 24 volts divided by 12 ohms, you get 2 amps. And that's the proportionality constant of Ohm's law. So an increase in voltage is always, usually, an increase in current, which is amps. And you need to know that current is created by bosons and electrons because of fermions and their interactions with bosons. And this can all happen uniquely in different atoms, giving them different values for currents and how they interact and how they bind and chemically, and how they do different things in the world of atoms. So, like, even molecules can behave very differently in their physical properties because they are bonded in different ways with different atoms. So, like, things are very uniquely weird. There's even things that may possibly create cyclic energy within the molecules or atoms. It may cause an electrical condition to occur, thus creating some cyclic electricity. That may be possible somehow. We haven't discovered everything about that yet, but here in this case I wanted to describe how a transformer works. So technically a transformer, step-up transformer steps up the voltage, but decreases the current by a ratio. So what that means is if we have 12 volts on a primary coil that's wrapped around a piece of iron in the form of a square, where 2 coils can reside on each side of the square. The copper coils that would wind around an iron core on one side is called the primary. It is the source of current that we're going to step up into the secondary with a double amount of copper coils on the secondary, where it catches more of those boson interactions and causes more potential current, not potential current, but potential voltage to happen. Now, the reason that this is simple, but the reason there's not also an increase in current is because basically the proportionality of resistance has changed. We have 12 volts that is multiplied by 2, that gives you 24 volts. But the problem is, when we multiplied our current, we also had 12 ohms multiplied by 2. When we doubled the copper coil on the secondary to increase the voltage, to step up the voltage in an AC current. Basically, it doubled the resistance. So therefore, the amperage is not going to be times 2. We doubled the resistance, so now the ohms are 24. So if you say you have 12 volts at maybe 1 divided by 1 ohm, you have 12 amps. So, in the fact that you're doubling the current and doubling the resistance, you would now say 20, you would say 24 volts. So you doubled the coil divided by 2 ohms. Okay, so equals that. That would be 12 amps, just like we had before, 12 divided by 1 ohm. So we doubled that. Now we have 2 ohms of copper, and basically the amperage has stayed the same. So like my question is here is, why does let's think about it here. 12 volts at the amperage would be, it's E divided by R divided by 2 divided by 1. No, we'll say 2 divided by 2 ohms equals 6 amps. So that is doubled in the ohms. So it would be, now it's 24 volts divided by 4, which is 6. So therefore 100% efficiency of the transfer of electricity, you have the same amount of current technically in a transformer. And they say that transformers are almost 99% effective at transferring their energy, especially if they're designed properly. So you can step up the voltage, but you don't increase in current because the resistance doubled. So you're still going to have your same amount of amperage, but the actual boson interaction, is going to be slower because you have more dynamics in the resistance of the copper coil and the magnetic field of the transformer on the secondary. So therefore, electricity is going to be resistant. That's what resistance is a deterrent of the flow of energy. It's a decrease in the flow of energy. So because you have more coil windings in the secondary, you're deterring the flow of electricity. And how that happens is quite quantum, and you really have to draw out all the dosages of atoms in the coil and how that all fits proportionally and how that can transform into a lot of different motions of particles and energy states. But basically, that's how it works, is that the electrons will travel in different directions, and it causes opposites to move in different directions, and because one part of the coil has more charge while other part has the opposite charges, it pulls it away from flowing from its potential difference to the resistance by being the resistance being increased. So the thickness of anything that conducts electricity can affect how much current it will have. And then also there are other factors like overloading a circuit to the point where it becomes at a high temperature. That also affects how current flows. So this is my video on how transformers basically work. Really basically, without seeing a picture, basically you can step up the voltage, but by doubling the resistance of the coils, or whatever your amount of difference of coil is, you cannot increase the electrical current. And voltage is not the only thing that does work, because if electricity is flowing, basically this is also what I want to get at, is that 6 amps is 6 amps. And you might increase the voltage, but it's only in a part of the circuit at that point. So basically, what you're doing is creating an amplification in a circuit. And what that amplification does is basically cause boson interactions to increase in energy. And that may add heat to the system, basically causing electrons to actually gain energy. But 6 amps is 6 amps, and both sides of the spectrum, you really, it appears as though you're gaining energy, but really and truly, you're losing energy equally when you increase the resistance of the coil. So basically you're not really gaining anything, because the net energy is 6 amps. But the voltage may be higher, so it's just really not really a gain of energy. So any kind of a voltage meter tells you in this circumstance where you turn 24 or 12 volts into 24 with a step-up transformer, you're still going to have 6 amps on both sides. And that is what is equal to energy, because when electrons flow, you have the ultimate energy. However, electrons might be considered bosons. They're the largest bosons. And what you need to know is that even though the voltage is increased, it's kind of like a little lie, because it's only increasing a little bit of energy, because there's really no energy increase, because you took it away when you increased the resistance. You still have 6 amps. So 6 amps is 6 amps on both sides. The only thing is that the coil is increasing in temperature when you increase the voltage. So that just kind of shows that technically proportionality law is a piece of crap. This is what they've learned, that for some reason in quantum physics, the proportionality of transformers is just not magical. It doesn't ever create additive energy, an additive force. There's always neutrality that takes away the positivity. Neutrality and negativity take away positivity. And that's really what's happening here. So it may appear that there's 24 volts, but that just means potential energy. That can only be measured accurately by loading the 6 amps. You have to measure the amperage, not necessarily the voltage. The amperage here is more important, because 6 amps is 6 amps, and that is the stronger force. And electrons are the more powerful boson energy. So all the energy is being put into the coil on the secondary. And that means that somehow it is actually multiplying energy, but your net here, your net and your gross is 6 amps at the same time. So it doesn't appear as though you've gained any real energy, except for in the secondary coil itself. But its output is 6 amps. So you have no real true gain, except boson energy. That's very strange to me. In a world that would operate properly, I would think that if you increased the amount of energy, that you should get an increase in the flow of energy. But really, you're not, because you're increasing the resistance to do it. So what that means truly is that transformers are not the answer to energy. They just manipulate energy in some way, but that doesn't mean that they are additive or multiplicative. Transformers and coils really have nothing to do with creating energy. So don't look for transformers or coils to have anything to do with creating energy. And perpetual energy has nothing to do with transformers in this case. In probably all cases, really. I'm not sure about that, but I'm going to say most likely, anytime you increase resistance, you very well might be increasing, most likely be increasing the resistance of the flow of energy. And that means less, and less is negative, and that means you're not going to continue with creating more and more energy. So that's my video on voltage and transformers, and how we can't create energy without having a source of energy. That source comes from basically a reaction or an interaction that is positively charged, thus creating energy in a world that seeks to be neutral and stable instead of positively charged. The only real true energy comes from either nature, which is mostly what is able to survive on this planet, is energized nature, especially from the sun. But like even gravity or biology has particle charges. There may be some forms of perpetual chemistry that may exist, but atoms themselves are perpetual, and they're in perpetual motion. So you want to know how to replicate that, and it is quite complicated with a system that is relentless to seek to be stable. Pretty sure that except for radioactive atoms, most likely everything seeks to be fairly stable, and that is not a good thing for the universe, in our part of the universe, or the multiverse. That everything seeks to be stable is detrimental to us, and that is what the problem is with everything that we do. We have to create energy, and it comes from a machine, basically, and that machine produces chemistry that causes a reaction, basically, and the chemicals react, and we get energy and pressure, and then we convert energy and transform it, and that's what we do. So there is no energy for real. The most energy is gravity and the sun and the moon and the core of the earth. Other than that, it's biology. Other than that, there really is no energy to be had. There's no energy in life. Life is almost barely alive. There's just no energy. You can't. You can get away with doing a little bit of work to create a sufficient amount of energy as a human being, but it does wear you out, and basically it's difficult. So that's the rebuttal, is that we don't have energy. Energy is just barely within us. Energy is not the answer in this universe. So we're going to have to create new forms of atoms called superatoms that are unstable and stable at the same time, that are much different than regular atoms, and they will cause exponential, hopefully, this is hypothetical, but hopefully these superatoms will cause energy to happen perpetually, like a nuclear reactor would. They may oscillate electrons and create exponential amounts of heat, causing a very quantum interaction. But we have to seek to create these atoms, and it may save the world from losing all of its energy. But that's pretty much it. Thanks for watching my video.